In this lesson, we're going to look at polynomials and their zeros. And we're going to look at descriptors like single, double, and triple roots. And you need to know what that means graphically. So let's review some things. Some of it you know, but a single root just looks linear. Okay? It just looks linear. That means it just cuts through the graph. No funny business. Easy enough to visualize and see. Like this. Just cut through the x-axis. Or if it's an odd number, you could do like this, right? Just goes through, no funny business. We just say it cuts through the x-axis, okay? Now, what if it is double? If it's a double root, we said it's going to act like a vertex. Okay, it's going to act like a vertex. So what does that mean? Well, that means it's going to bounce off the x-axis. Now, if it could just do this, something like that, just touches one place, but it bounces because it's double. Or it could bounce and look something like this. All right? Like this one actually cut through over here, but this one is a double root right there. So here's the bounce. This one is not a bouncing root right here. So think of like parabola, right? It bounces off the axis. Now, the third kind is a triple root. Now, this one we haven't discussed before, so it may be different. So we say it looks flattened. Okay, it looks flattened out. So what does that mean? Well, that means that when you graph it, you kind of slide through. All right, so what do I mean by that? Well, let's say I have a root right here. So as I draw it, I kind of aim just a little bit to the left of it. So it kind of has to flatten while it sits on that x-axis just a smidge. So again, if I have two, let's say I have a single root right here and it comes up, but this one over here is going to be a triple root. That means I aim a little bit to the side of it so it will sit on that x-axis, okay? Here's my triple. Right there, okay? Or you could say a slide through it, whatever you want. But you got to know the difference. Now, double and triple, all of these really are multiplicities, okay? Now, single is understood. We don't have to write single if it's a single, but if it's a double, you definitely need to notate that. And if it's a triple, you got to notate it. Otherwise, how would we know, right? So today, you're going to look at factored polynomials. So they've done the hard work for you. Your job is to look at the zeros that come out of it and predict a little bit of what that shape is going to look like. So let me show you what I mean. Number one. So what I want you to do first is think about if you multiplied all this out. Don't actually do it, but if you multiplied all this out, you'd have a negative 1 times x, which means it'd be negative x squared, right? So let's just think in behavior. If it's x squared, it's going to look like a parabola on the ends, and it's negative, so it's going to be pointing down. So it's important to kind of jot that down so you don't have to remember it as we go further. But it will help as we do our sketching later. Now, let's look at our factors. Take each factor, set them equal to 0, and solve for x. So x is negative 1, x is a positive 3. So now I'm going to sketch myself a graph. Now you don't have to be super accurate here, but draw it where you can see all the zeros. We know there's a 0 at negative 1, some kind of intersection there, and we know there's 1 at 3. We know that the ends point down, right? So as I draw my graph in there, it's going to look like this. These are single multiplicities. There's no funny way that it's going through. So that's all I have to do. Here's my zeros, and here's my sketch. Now, I don't need to state any multiplicities because these are singles. It's understood. Let's look at number 2. All right, first of all, let's think about our end behavior. All right, if I multiplied this, negative x times x would be negative x cubed, right? That's an odd one. And it's going to go in the negative direction. But my ends are going to go in opposite directions with like a negative slope. Now let's look at our zeros. Where is it going to cross that x-axis? So each part of this I set equal to 0. And solve it. Well, this one just gives me an x of 0. This one gives me x of negative 2. And this one gives me an x of positive 2. Wonderful. So I have 3 places. They're all single multiplicities. So let's look at our graph. Let's think about this. I have a negative 2, I have 0, and I have positive 2. Okay? I know it's going to start from left to right. It's going to come up, and it's going to cross through. So it's going to cross through, cross through, cross through. And there it is. Let's look at number 3. This one, if I multiply my x's, think about this. This is x squared, right? Times another x gives me x cubed, and it's positive. So what does that mean? Well, it's going to function like an odd function and going uphill. Now, let's come back and look at where is it going to cross. So x plus 6 equals 0, x plus 4 equals 0. So x is negative 6, but notice that 2 right there. This is a double. So I have to indicate that. This will be x equals negative 4. But it's just a single root, so I don't have to worry too much about that. Now, when I graph this, I gotta make sure I give myself room here. 1, 2, 3, 4, 5, 6. So I'm gonna have negative 6 and 1, 2, 3, 4. And I know my ends are gonna go opposite directions, right? Now, what's happening in between? If it's a double root, that means it's gonna hit that x-axis and go back the same direction. And then I just connect my points, right? Now, mine's not perfect, but you get the idea. It's bouncing off that x-axis. Number 4, let's look at our end behavior. X third to the third times another x will give me x to the fourth, and it's positive, so that means they're going to go both ends in the same direction, pointing up. Now, let's set our factors equal to 0. So x is negative 1, that's a negative, and x equals negative 5. Okay, so again, I need to look at this. Look at my power. That 3 means this is a triple. So I need to indicate that. This one's a single. I don't have to write anything there. But let's think about our graph. What is going to happen here? Okay, I know it's going to hit at negative 5, and I know it's going to hit at negative 1. I also know the ends are going to go in the same direction, right? So this one is going to cut through. This one is going to slide through, so I need to come up just a little across from it and then do that. There's my triple. There's my slide. Okay, so make sure your drawings show me that it's a slide. Don't make it look like a cut through. If I can't tell it's a slide, I'm going to treat it like a cut through. Now this last section is kind of undoing what we just did. It says write the polynomial in standard form with the given zeros. So we're going to take basically what we did here and work our way back to the factored form and then multiply them out. So let's take one step at a time here. Let's look at number 5. All right, first of all, we're going to find the factors that give us these x values. So if you remember, it's just changing your sign and putting it in factored form. So a negative 2 came from an x plus 2. A positive 1 came from an x minus 1. Positive 4 came from x minus 4. And now I just need to multiply these out. So just start 2 at a time. Just do FOIL here. So I have x squared plus x minus 2 times x minus 4. Now when I multiply a trinomial by a binomial, I'm going to make myself a box. And I'll have x minus 4. All right, then we'll do this. X to the third, x squared minus 2x, negative 4x squared, negative 4x, and I multiply, this will be positive 8. Then if I did it right, my like terms will be on the diagonal. So this would give me y equals x to the third, these two go together, minus 3x squared, minus 6x plus 8. And there's my answer. So this is the standard form of the equation. Let's try the next one. All right, this one, an x plus 1 gives me negative 1. Notice I have it twice. What gives me a 0? Well, just a nice little x will give you a 0. So I just put that out the front so it's easier to gather together. And then a positive 2 would come from x minus 2. Okay, so I'm going to FOIL these two first. So I'll have x squared plus 2x plus 1 times x minus 2. Now I'm going to distribute this x across. So I'll have x to the third plus 2x squared plus x times x minus 2. And now I can do that little box that we talked about. X to the third plus 2x squared plus x. And then we have x minus 2. So when I multiply these like a Punnett square, I multiply 2x to the third, x times x is x squared, minus 2x to the third, minus 4x squared, minus 2x. All right, let's combine like terms. So I have x to the fourth. These two go together, but look, they cancel each other out, don't they? So these two are my next terms. They'll be negative 3x squared minus 2x. There we go. Last one. All right, notice this one. Well, what kind of factor gives me negative 2? Well, an x plus 2. What gives me a 0? An x. What gives me another 0? Another x. What gives me a 3? X minus 3. So I'm just going to combine these two and make them x squared. And then I'm just going to rearrange. So I put my binomials together. Now I'm going to FOIL. So I'll have x squared minus 3x plus 2x will give me minus 1x minus 6. And now I don't have to do a fancy box. I can just distribute. So I will have y equals x to the fourth minus x to the third minus 6x squared. All right, so there's my answer in standard form. All right, I hope you have understood what we've done. Please let me know when we get back to class if you have questions. Good luck. We'll see you then.